this video, we'll find the average value of a function. This is a 6.5 pre-class video. Alright, so we're going to be looking at how to find the average of a function on a certain interval. Well, first we'll look at taking the average of a finite number of values. So say the values are y1, y2, all the way to yn. So you have n values that you're trying to average. We'll just add them all up and divide it by n. So for example, if n equals 100, and you have 100 values that you're trying to average, well, you add them all up and then divide by 100. That'd give you the average of the 100 values. We'll say these values came from a function valued at x1, x2, all the way to xn. And we could write it in summation notation. Let's imagine that x1 all the way to xn were equally spaced by delta x. And so if you're on some interval from a to b, then delta x is equal to b minus a divided by n. And since there's a 1 divided by n term in our summation, we can solve for 1 over n. That'd be delta x over b minus a. And substitute that in now into our summation formula. And since 1 divided by b minus a is a constant, I can factor that out of my summation. So what we have so far is a formula written in summation notation of finding the average value of a finite number of function values, where the function values are equally spaced horizontally according to delta x. But on an interval from a to b, our function takes on an infinite number of values, and we don't want to take the average of just a finite number of values. We want to take an average of an infinite number of values on the interval from a to b. Well, hopefully this last part of the equation looks familiar, because if we take the limit as n goes to infinity, well, our formula turns into the definite integral. And there we are. The average value of a function on an interval from a to b is 1 divided by b minus a multiplied by the definite integral from a to b of our function f of x. Well, that's it for this video. Hopefully you are all warmed up for class.